Hi, my name is Fernanda,
And my name is Javi.
and in this video, we'll show you how to set up UART serial communication on the STM32F411RE board using register level programming. We'll transmit text to a serial monitor. In this case, we're going to be using real term and using USART2 without any external libraries. So we're going to go step by step on our code to show you how the microcontroller sends data to the computer.
First, we have to understand some definitions and what is a UART. A UART, or Universal Asynchronous Receiver Transmitter, is a communication protocol that allows two devices to exchange data serially, one bit at a time. Now, in the code, first we have to define some constants. First, we have GPIO A EN, which is the bit to enable the GPIO-A clock. Then UR2EN, which is the bit to enable the USR2 clock. Then the SYS freq, which is the system clock frequency that is by default in 16 megahertz. And also the UART bound rate, that we will use a bound rate of 9600 for communication.
So after that, after we've defined our constants, we're going to declare some pointers to registers that we need. As we can see, first we have this port A HB1 ENR, APB1 ENR, GPIO-A moder, and GPIO-A AFRL, and all of their base addresses that we can find on the STM32 datasheet. All of these are going to allow us to manually configure both the GPIO-A pins and the USART2 peripherals, which are these variables here, these pointers.
Now for the main function, we first initialize a UR2 for transmission. Then inside the loop, we send a message. In this case, we have experiment 3, which it's gonna repeatedly to the serial monitor.
Now we have the function UART2 tx init. This function is the UART initialization. It does all the setup for transmitting with USART2. First, it enables the GPIO-A clock with this line here. Then it's gonna enable the USART2 clock. After that, it configures the pins in A2 as an alternate function with the AND operator to clear and the OR operator to set a value. Then we select the alternate function 7 or AF07 for the UART-TX on the pin A2. And in here, this binary value that is 0111 is going to select the alternate function 7, which corresponds to USART2TX. Then we're going to set the baud rate. This sets the baud rate to the 9600 for a 16 megahertz clock. And finally, here we're going to enable transmission and USART2 with these both lines. Transmit and enable and the USART enable.
Now with this function, we'll send a single character. The first while waits until the transmitted data register is empty, and the second, the next line, writes the character to the data register. That's how we're gonna send the characters we wanna show.
Then with this function, we redirect the printf to use the USAR2 write function, allowing us to use the printf just like in regular C programming, but now it sends data through the UART.
So as a summary, we have that this program enables clocks for GPIO-A and USR2, also configures port A2 as UART using alternate function mode. Also initializes USR2 with a baud rate of 9600. Redirects printf to send message via serial and will continue print the message we want to show. In this case, as I said, experiment 3.
Okay, now in this video we've opened the real-time serial monitor and we're gonna run the program to see how the message is printed now in the computer screen. But first we need to go to the port section and choose the adequate baud rate option according to the one we defined, and then choose the port, checking which number it is on our device manager. And as we can see, the message we wrote is printing continuously on the screen. Now we can also change this message to demonstrate how it's working. So we're gonna write some other words, and after that we need to build the program again, debug it, and then run it so we can see how it's printed on the serial monitor again. And now we see that our new message is continuously printing on the screen with the configurations we chose. So that's it. Thank you for watching.